Yes, students, today we are starting with the solutions chapter in class 12th. What are solutions? We have already done this part that solutions, they are homogeneous mixtures. A solution is a homogeneous mixture uniformly. The components, they will mix up here in a solution. And in this, there can be two components or more than two components also. So solution is a homogeneous mixture of two or more pure substances. Pure substances means these can be elements or these can be compounds. Elements and compounds, they come under pure substances. Now, like we have done here, there can be two or more substances in this, but we are restricting our topic only to binary solutions where there will be one solute and one solvent. So there are two components we can say in a solution. One is solute and the other one is solvent. What is a solute? That is present in a small amount in solution, and solvent basically is the one that is present in large amount in a solution. Next, after this, we have types of solutions. How many types of solutions are there? Based on the physical state of solute and solvent. That is, the solute is in a solid state, liquid or gaseous state. Similarly, solvent is in a solid state, liquid or gaseous. Depending on the physical state, solutions, these are of 9 types. So, physical state of solute. Then we have the physical state of the solvent, and then name of that solution and example of these solutions. So physical state of solute here I'm taking, that is, we can take this in a gaseous state, liquid state and in a solid state. And then after this we are taking again gas, liquid, solid. Then again I am taking gas, liquid and solid. And solvents I am taking gas, here I am taking liquid, and in the last three I am taking this as solid. Now, name of these solutions are very easy. When the solvent is in a gaseous state, then these solutions are called gaseous solutions. And when solvent is in a liquid state, these are called liquid solutions. And here, when it is in a solid state, then this solution is called solid solution. Examples of these solutions. When the gas is mixed in a gas, example we can take is air, in which we have a mixture of various gases like oxygen and nitrogen. When liquid is mixed in a gas, like we can say humidity present in air. Next is solid in a gas like iodine vapors in air, camphor in air. Next we have liquid solutions. When gas is mixed in a liquid, the example is aerated drinks or soft drinks. Liquid in liquid, the miscible liquids like ethanol in water, you can take the acetone in water. Then solid in a liquid. Basically these solutions only we study, like salt in water, sugar in water. Next after this, we have solid solutions. Gas in solid, we have done adsorption. So hydrogen adsorbed on platinum surface. Liquid in the solid, hydrated salts, the salts which have water of crystallization. Then solid in solid solutions, example is alloys. All alloys, they come under which kind of the solutions? Solid in solid solutions. So these are the 9 types of solutions based on the physical state of solute and solvent. But whenever we deal with the solutions, one thing is very important that we should know, that is concentration of solutions. So our next topic is concentration of solution. So why concentration of solution is important when we are dealing with the solutions? Solutions are made up of solute and solvent. Like solutions are prepared by two students having the same solute and solvent. Like copper sulfate solute was given to them and water solvent was given to them. And they were asked to prepare the solution of these. So one child took 100 ml of water, another child took 200 ml of water, one child took 10 gram of the salt and added to 100 ml, another one took only 5 gram and added to the 200 ml of water. The two solutions are of copper sulfate and water, but how the two are different in the amount of solute and solvent in them. So the solution is prepared with which concentration? That is very, very important when we are dealing with the solutions. And there are different ways to express concentration of solution. And these different ways only we have to study. This is our next topic, that is the ways in which we can express concentration of solution. First I'm taking is the percentage. Percentage by mass, written as W by W. So what is the meaning of percentage by? It means how much amount of solute in grams we are taking, mass of solute in grams present in 100 gram of solution. If total 100 gram solution we have taken, how much is the amount of solute present in it? That is called percentage by mass. Next is percentage by volume. This is used for the liquid solutions when we have both the components in a liquid form. Percentage by volume written as V by V. So in this case, instead of the gram, we will take the milliliters. So I'll say volume of the solute in milliliter in 100 ml of the solution is called percentage by volume. That is volume of solute in milliliters in 100 ml of solution. That is called percentage by volume. Now third here is the molarity. Molarity is written as mole per liter and denoted by a symbol capital M. Now what is molarity? Molarity is number of moles of solute in 1 liter of solution. That is called molarity. And molarity formula is its number of moles of solute, and moles are equal to mass upon molar mass. So we can write mass of solute upon molar mass of solute into 1000 upon volume of solution in milliliter. Since this is in 1 liter, so to change this volume which is in milliliter to the liter, it is divided by 1000. That is why this 1000 is coming here in the formula. And what is this part? Mass upon molar mass is the moles of the solute. So this is the molarity. After molarity, next term we have is the normality. Normality is gram equivalents per liter denoted by a symbol capital N. Now what is normality? It is the number of gram equivalents of solute in 1 liter of solution. Formula for normality, symbol is N, is equal to, we need the gram equivalents. Now what are gram equivalents? Moles are mass upon molar mass. Gram equivalents are mass upon equivalent mass. So this formula will become mass of solute upon equivalent mass of solute present in 1 liter of solution. So this is 1000 upon volume of solution in milliliters. And this mass upon equivalent mass is gram equivalents. So we know what are gram equivalents. But now what is equivalent mass? Coming to equivalent mass now. Equivalent mass is equal to molar mass divided by acidity or basicity. Now question here is, what is acidity and basicity? Acidity is for the basis. Acidity we use for the basis. What is acidity? The number of replaceable OH minus ions in a base. Example, NaOH. Acidity is 1. Calcium hydroxide, there are 2 replaceable hydroxyl ions, so its acidity is 2. Next we have basicity. Basicity is for acids. And what is basicity? It is number of replaceable H plus ions in an acid. How many H plus ions are replaceable in an acid? That is equal to its basicity. Example, in HCl there is only one hydrogen which is replaceable, so its basicity is 1. While in H2SO4, 2 hydrogens are replaceable, so its basicity is 2. So this is about the normality. Moving on to the next concentration term, that is molality. What is molality? It is moles of solute in 1 kg of solvent. So it is represented as moles per kg, but this is per kg of solvent, remember. Designated by a symbol small m, while molarity is designated by a symbol that is capital M. What is molality now? See, in the name only there is mole word here. That means it is number of moles of which substance? Of solute. Number of moles of solute present in 1000 gram of solvent, or we can say 1 kg of solvent. The formula for molality is, this is equal to moles of solute. Moles means mass of solute upon the molecular mass of solute into 1000 upon mass of solvent. But this mass of solvent we will take in grams. That is why we are using 1000 here to convert it to per kg. So what is molality? It's the number of moles of solute present in 1 kg of solvent. Now next concentration term is mole fraction. Fraction of which thing? Of moles, designated by a symbol X. Now if there are 2 components, let's say A and B in a solution, the fraction of moles of A component is XA and of B is XB. So what is XA? Mole fraction of A component will be equal to number of moles of this component divided by the sum of number of moles of all the components in a solution. So there are just 2 components in a solution. So this is a sum of number of moles of A plus that of the B. Similarly, XB will be equal to number of moles of B component upon that of Na plus Nb. And sum of mole fractions, like sum of fraction is always equal to 1. Similarly, sum of mole fractions is always equal to 1. This is mole fraction. Now moving on to the next concentration term, that is the last concentration term we are doing, is ppm. Its full form is parts per million. In 1 million, how many parts are there of a solute? Parts per million. This concentration term is used for very, very dilute solutions. Like if we have to tell the pollution in an air, then we use this concentration term. So this is mass of solute present in 1 million parts by mass of solution. So we are using masses here, like we have to tell the parts per million of A component. So ppm of A is equal to the, it's just like percentage only, just see mass of A upon mass of the solution. In percentage we write into 100, here it is parts per million, in million parts, so here this one will be 10 raised to power 6. Now after these concentration terms, we have to note down the things to solve the numericals based on concentration. The 2 points we are discussing here. The first one is, if we take an acid or a base and just changes concentration, same acid or base but changing its concentration, then if we have to find out the concentration of the acid which is diluted, which is changed to the different concentration, let's say first acid or base that we have taken, its molarity is M1 and the volume of this one is V1, and when suppose we dilute it, then its molarity will change. What is its molarity? Multiply with the volume. Using this equation we can find out 3 terms. If we know from this thing, fourth one we can find out. And similarly, in place of the molarity, if normality is mentioned, then we can replace the molarity by normality and use this equation. Now second point here is, if to one acid another acid is added, when to one acid another acid is added, or to one base another base is added, then when we mix the two, after mixing, what will be the molarity or normality of the mixture, the resultant solution? For this we will use this formula. We cannot use this formula now because the two, they will react and the molarity will change here. So the new molarity will be M3 into V1 plus V2. So using this formula we can find out the molarity of the resultant solution after mixing one acid to another acid or one base to another base. And if there is normality mentioned, then we will change this formula to, in place of molarity we will write normality, and this one will be a formula to find out the normality of resultant solution. So this is about the solution, different type of solutions and the different ways to express concentrations of solutions.